In this problem, we're going to graph the function f of x, and we'll do that in a green line, and its inverse, and we'll do that one in a purple line on the same grid, and then we'll dash in the y equals x line, and we'll do that in a red line. And then we'll note how the graphs are related and verify the inverse function relationship using composition. So I know that the family of the cubed root function looks something like this shape. And this plus 2, since that's grouped with the x, that means it's a horizontal shift in the opposite direction of the sign. And so that's a plus 2 means I'm going to shift that left 2 points. So that's 1, 2. I'm using that center point as my point of reference right here. So that center that was at 0, 0 is now 2 units left of that. In the purple one, I know that the family of that x cubed family looks like something like this. And I know that minus 2, notice it's not grouped with the x, it's attached on. If it was grouped with the x, it would look like this. Cubed minus 2, it's not in a group with the x. So since it's not like that, it's actually tacked on. That means it's a change in y. And the vertical shift is a shift down. So that keeps the same sign. So that purple line, let's see if I can get just the purple one, will shift down 2 points. So that center point, I'm going to go from that center point, I'm going to go down 2. 1, 2. This little guy came along. Okay, so there's my two graphs of the inverse function, and then my xy line, I'll use my straight line tool for that with a red, and I'll do instead of doing a dashed line, I'll just do a really light line so I can do a nice straight line. The y equals x line, that's when x and y are both 0, and then both 1, and then both 2, and then both 3. So it's that straight line right through the x and the y having the same values. So it looks like that. And you'll notice now the relationship. How are these graphs related? It's flipped over the x equals y equals x line. So the relationship is reflected or flipped over the y equals x line. All right, now my favorite part, to verify with the composition. That's 2 parts. That means I have to find f of f inverse of x, and I have to find that that is equal to x. That's something I had to prove. And I also have to prove that f inverse of f of x. So I need to be able to go both ways, and find that f will undo f of f inverse, and f inverse will undo f. So let's start with that first one. So f of f inverse, our f inverse is this thing. So that's going to be x cubed minus 2. That means I take f, which is this, cubed root of x plus 2, and instead of f, I write this. Leave a little more space there. So x cubed minus 2. So I'm going to write, instead of x, I write x cubed minus 2. So I'm taking f of f inverse. All right, now to evaluate this, looking under the radical, I can take out that, I can move that parenthesis around with addition, because addition is associative, so I can change the order to be plus a negative 2 plus 2, and that becomes the cubed root of x cubed plus 0, which is the cubed root of x cubed, which is just x, and that's my check. Okay, so let's repeat that process, reversing it. So this time on the outside I have F inverse. So I have F inverse, and on the inside I'm going to put the f of x, which is cubed root of x plus 2. And I want to make sure that's going to equal x. So that equals, F inverse is x cubed minus 2, but instead of x, I put in this thing. So that's the cubed root of x plus 2. So I'm just rewriting F inverse with, instead of x, I write f of x. Okay, so the cubed root of a cube is just whatever's inside. So the radical goes away, and I get x plus 2 out, minus 2. And then I can move the parentheses around because addition is associative. So I get a plus 2 minus 2, which equals x plus 0, which is just x. So I verified it both ways. So that means I have verified it using composition. And this is crucial. So you want F composed with F inverse and F inverse composed with F, which is what we did in blue and purple.